So last weekend I showed you this PCB design and the fact that I'd just ordered it from China and sent all my Gerber and drill files off and just got through the vetting process. So I placed that order last Saturday. Within 24 hours I got a message saying it all been manufactured, which is fantastic. And then I started getting messages from DHL, the courier, and yeah, they arrived on Thursday. So, you know, given that this is somewhere in the midst of China and remotely sending them these files, and they've manufactured it and shipped it and got here successfully, I think it's fairly incredible. So let's just have a quick look at them. So here they are. There's the boards, exactly really as I intended. There's a couple of things probably would change next time. First of all, these fidicials, they've ended up on the silk screen, and I've looked at where I went wrong in the CAD model, and I can see that it was set to silk screen. It shouldn't have been. It should have been just under fabrication, and there's an actual setting for defining them as fidicials, so they don't get printed on there. And then the font here is a little bit small and difficult to read. Maybe the colour could do with changing, but other than that, they're absolutely great. They're solid, fiberglass, yeah, absolutely fine. So if we put these side by side and have a look at the model, there we go. So that's the front. Turn it around. So there we go. You can see there. Yeah. And of course I've got the components shown here, but we can turn that off. This one here, there you go. So that's more realistic to what it's like. Okay, so it's bang on, exactly what we designed. So the next step then is to put all of these components in and try it out. And yeah, I have already tried that, so let's have a quick look. Let's just change the camera view again. There we go. And bring this version in. So I've wired in the 6 volt 4 AA cells into the 6 volt input. The Arduino Nano Every is in place. The Schmidt trigger, hex Schmidt trigger circuit is there. The capacitors, resistors, all of the connectors have been put on and the header pins are put on. Yeah, and then I've made up some adapter cables for standard rotary encoders. That's rotary encoder 1 and rotary encoder 2, and a little lead to drive the LCD display. So let's just put the last battery cell in and fire it up. And I just got a little test sketch running on the Arduino, which will show me the inputs that it's receiving from the 2 rotary encoders. So first of all, great, the LCD is working, and if I turn rotary encoder 1, hopefully you can see that count, and it's absolutely spot on. There's no glitches whatsoever. Yeah, click, 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 click. Nothing is missed, and it doesn't jump around erratically or anything. If I press the button, you can see the button count is going up. Absolutely fine. And I can do the same with rotary encoder 2. Forwards, backwards and so on. Press the button. That's absolutely fine, and I can do the 2 together. Rock solid, absolutely rock solid and stable. I'll turn that one and press this one. Oh, it's got my hands in the way. Yeah, so you see the button count is going and the rotary encoder at the same time. Both rotary encoders. Here you go. And if I hold this, I'll set it to go back to 0 if I hold that for 2 seconds, and similarly on this one. Yeah, so that doesn't serve a lot of purpose other than just test that the board is working. So now we can take this board and use the other IOs to develop a project, but all of this is now done for you. So that could be a menu control on here. It might drive a stepper motor or all kinds of things. You can do what you like with it now. But the idea was to get this stable Schmidt trigger input for the rotary encoders and the push switch. So you're not forever messing around getting that wired up each time. All right, that's all good as far as I'm concerned. I'll catch you later.